An Introduction to Deep Water Culture, or DWC. Deep water culture, or DWC, is perhaps the most iconic version of hydroponic production. So if we take a quick look at this picture here, you can see, we've got this greenhouse structure all around. We have these bays just absolutely filled, brimming with these rafts of plant production. And so we just see this large pool, right? This deep water. We have this large pond of water. So we've got these individual units, these rafts of plants. You can see them one here, and then another, and then another, and they just kind of go off. And you see how that color change happens back here? We have the smaller, younger plants have been placed in the rafts here. They've grown up a little bit. These are ones are older. But the point being, this DW, the deep water, we have ponds in this whole, under this whole greenhouse are these ponds or pools. So deep water culture is also one of the most accessible versions of hydroponic production, because whether you start with a bucket or some kind of tank or trough, anything able to hold a good amount of water, a deep amount of water, can suddenly become a hydroponic production. Now, while deep water culture may be the most accessible version of hydroponics to get into, because we just need this pond, and then we just put rafts on it and we're off and growing. This version of hydroponics does not give us any additional gain on land-based production. So if we have one of these rafts and we're looking at it from the top down, if this was land-based, soil-based production, well, this is how much space we have. Maybe, 1 foot by however many, let's say 6 feet. So we have 6 square feet of production potential. This, whether it be land-based or water-based, this is all the space we have. There's no gain on vertical growth. We just are packing in the plants as tight as we can, but still limited to the same plot of land that we started with. One reason we have to avoid this vertical production, the vertical gain, is this deep water. Water's very heavy, and so if we have deep water, if we have these huge ponds of water that we need to support all these rafts, then we can't very well put a bunch of water up above that raft to give us a new raft, right? So while deep water doesn't give us any gain to productive area, we do stand to reap a few other benefits. Can you picture some that come from having a large volume of water? One thing is that we have a good amount of thermal stability. This high thermal stability from that large water volume means that as temperatures fluctuate, this water doesn't change as quickly, which means your crops receive a much more stable temperature across their growth. We gain a high degree of chemical stability as well. So again, large water volume. That means it's hard to change the temperature. It means it's hard to affect the chemistry. So if you have a problem with your input water, this can be a more problematic approach because you have a lot of water that you then need to treat. But if this water is all good, then it's very hard for these parameters to shift across time. It takes a lot more to change something like pH, or, well, pH is the most important one. So we have a more stable pH as the crops are growing. As the chemistry is changing in this deep water, there is so much of it that the changes are diluted and take longer to build up and cause an effect. Independent of the large water volume, deep water culture has very simple, low maintenance. So since we have such a large volume of water, we don't need to be supplying as much of it or pushing around or making the best use of our limited amount of water. With such a large volume of water, we don't typically have as frequent a need to refresh. This itself also means that we have fewer pumps and less piping in general. So just a simpler system, less things to maintain, fewer things to break. Possibly the single biggest moving part of the system. Let's see if we can get back to this slide. Can you see it? Yeah, all right. Biggest moving part of this system are these rafts that I pointed out in the beginning. The younger ones are back here, so what probably happened is we had a harvest here, new ones are put in back here. We'll actually have new transplants still to push in behind these and move everything forward. So less pipes and pumps and all that need to, that can potentially break. And also there's just fewer moving pieces, fewer things for someone to trip and break. Like these large ponds are a lot easier to avoid and harder to cause damage to than, say, if you had something on a table or even something like in a lean-to or frame of some kind. So perhaps you can see something lifted up, something on a more precarious frame. Both of these are subject to some danger of someone walking around like bumping the table or knocking it off down on the ground. Deep water culture already sits on the ground, is very large, is very stable. You're not going to just kick it and spring a leak. Which leads to the final resilience of this deep water. There's a far lower danger, much reduced risk from loss of electricity. So if you lost electricity and your pump turned off, these systems would run out of water very quickly as the water drained away down to the sump. All these systems would lose their water very quickly, and those plants would dry up and be really hurting pretty quickly. This has nowhere to drain. This is the reservoir. This is the sump. This is where all the water stays. And so if we lose electricity, we wouldn't be able to pump this water to aerate it. However, these plants themselves would not lose access to the water. All right, let's talk about some of the challenges. So aeration does become an issue. Your plants need air to grow, to breathe. Their roots need air to breathe. So when they are growing in this deep water, in this mass of water, if we've lost the electricity, there's still water there for the plants to take up. However, we're no longer able to pump in. As the depth of water increases, the ability for air to just naturally permeate it decreases, because air can only happen where the water's contacting the air, right? So that's at the surface already anyway. So we need this pump to push air into the water for the roots. And we need this more than any other system because this mass of water, this large water volume, is just sitting here. It's not being pumped around like in those other examples that I showed. Something to watch out for is the miscibility of gas into a liquid. So as temperature increases, so we have this high thermal stability of water, right? As the water temperature increases, diffused gas decreases. One of our other challenges in this deep water, the large water volume of deep water culture, as I mentioned at the beginning, is the sheer weight of this. We are not gaining productive area because we can't stack this system, because this water is far too heavy. Does anybody want to take a guess? Do you know about how much water weighs? Water weighs about 8 pounds per gallon, which means 3 gallons of water equals about 25 pounds, while a cubic foot of water equals about 60 pounds. So a cubic foot of water, here I have a ruler. A cubic foot. So one of these by this. So about this much water. Does that make sense? Haha. 60 pounds. This much water. 60 pounds. And that's enough, as we saw from those pictures earlier, about that much water. You're putting how many plants in that? Maybe 4? For a cubic foot, you don't have to go that much deeper. But every cubic foot, 60 pounds. So how are you supposed to lift that up? You don't really. So deep water culture, limited to a flat system because of sheer water weight. The last thing we have to talk about is just its simple construction, the simple construction features of deep water culture. There's only a few core components. You don't even need land, you just need a space. You need space. You need the bottom of your reservoir, and then of course the walls. So bottom, the walls. We need something to make the deep water, something to hold the water. Then of course you need your water. The most complicated, specialized piece that you'll need is a raft of some kind to put your plants in. So obviously it needs to fit within the floor and walls. It needs to fit within here. And the raft, you can either get a sheet of material that floats that you then drill holes into, or get something pre-made. Something pre-made saves you a lot of time in making it. They're also much more resilient. They don't have these open edges. Everything's been sealed and made back into one final piece, so you're not leaking things into your reservoir here. But get this raft, put it on top of your water. Then, as we talked about, a need for aeration. Dramatically not to scale. This air pump is not going to be half the size of your deep water culture. The last thing we will need is something to address this thermal stability. So water is very stable at whatever temperature is around it. If it is too cold, then you're going to need to heat it. If it is too hot, you'll need to cool it. If you're really lucky, the temperature coming out of your tap or source will be the perfect temperature for your crop. But otherwise, that temperature, what you need, is going to change depending on what you grow. Tomatoes want warmer water than do lettuce. Deep water culture. Start with a large water volume, gain a lot of benefits from that water, manipulate the water as needed, both temperature, aeration, chemical control, of course, fertility control. There we have it, the most simple, approachable version of hydroponics, this deep water culture or DWC technique.